This video provides an overview of the basic components of a studio day, which is one kind of job-embedded professional development. Job-embedded professional development, meaning professional learning that happens in authentic settings, is only one component of a larger picture to support teacher learning. Studio days are used in conjunction with other supports. During studio days, teachers collaborate to provide real-time feedback in an authentic teaching and learning space. Often when groups of teachers come together to examine student work using Critical Friends Group or video study, for example, the work comes from prior lessons or units. During studio day, however, teachers implement real-time feedback within current lessons. Also, the studio day model differs from the lesson study because the preparation is a process that occurs over 3 weeks and feedback happens both in real time and after each co-taught lesson. Studio days are an all-day job-embedded professional development where teachers and other educational stakeholders collaborate to give real-time feedback in an authentic teaching and learning space. In this video example, studio days included classroom teachers, coaches, researchers, and university staff who came together 6 times throughout the school year to focus on a shared set of core practices to improve science teaching and student learning and a set of specific goals. The goal for this group of educators was to help students develop explanatory models and create evidence-based scientific explanations. Studio days happen multiple times per year in different classrooms. Teachers take turns hosting studio days. Although studio days feature a wide variety of science content, the goal of each studio day is the same. In this example, it is to support students in creating evidence-based explanations of scientific phenomena. Host teachers collaborate with others to plan ahead for studio day activities starting approximately 3 weeks before they host the studio day and 3 days before. 3 weeks before the studio day, the host teacher and coach meet to decide on the trajectory of the unit and select lessons. They review the curriculum, next generation science standards, and determine a puzzling phenomenon for students to investigate throughout the unit of instruction. 3 days before the studio day, student work is evaluated to assess students' current level of understanding the phenomenon and to set appropriate goals based on the student progress now that the unit is underway. Finally, they plan a draft of the lesson to be used during the co-teach on the studio day. The team of teachers and other educators comes together for this all-day event. Here is a sample schedule for a 6-period day. The day starts off with a brief and co-planned session. First, the host teacher orients her colleagues to her unit the students have been engaged with thus far. The team discusses science content and asks questions. This next audio clip is an example of the briefing about how a man-made causeway has affected the Great Salt Lake ecosystem.
So, because this causeway was put in, it's cut off exchange of the water here. And so this area has become saltier and saltier and saltier. It's so salty that really only one organism lives there now. It's called the halobacteria. It's an archaea. It's not a bacteria. But it loves salt because internally its cytoplasm is also pretty salty.
And what were the percent?
This can range from like 3% to like, I think it was like 10 teens maybe.
Okay.
And this one can go all the way to like 30%.
Yeah.
Yeah. And the ocean I think is like 5 or 6%. So it's even this is much saltier than the ocean. So halobacteria is like a pinkish color. It photosynthesizes, not with chlorophyll, but with this something rhodopsin. It's a pigment that it has. So it photosynthesizes. Halo does not live down here though because it's not salty enough. And so what happens is if you put it in this concentration, it will lyse. And water goes in and it gets in, pops, lice, whatever, same thing. So, but down here there's a lot of biodiversity.
After the initial briefing and before the co-teach begins, the team decides what changes to make to the lesson that aligns with their goals of helping students develop explanatory models and create evidence-based scientific explanations. Next, all participants join the host teacher in her classroom. In this example, the host teacher launches the lesson with a question posed to students about the possible changes in a food web in the Great Salt Lake ecosystem. Students shared competing hypotheses with their classmates. Then they worked on revising their models using information from previous activities and inquiries. Teachers recorded and videotaped student conversations and probed for deeper understanding and greater connections. Here is a clip of a teacher pressing a pair of students to clearly explain changes to the Great Salt Lake ecosystem if it becomes too salty.
It doesn't mean that there's necessarily more brine shrimp to like it doesn't mean that it doesn't mean that there's going to be like now the halo affects the other what did I say?
She right? How can she?
Okay, so like there's more halo, but so the brine shrimp like the halo, and the brine fly like the halo. But I don't know like how that, since there's leftover halo, I don't know that affects like the other, like the bird or the.
So you think that the halo is going to, can you tell me what's going to happen to their population
Increase because they're extremely frozen.
and what will happen to the diatoms and cyanobacteria?
They might become overpopulated, like they will do more.
So what do you think is going to happen to the other two on the bottom?
Does cyanobacteria and diatoms grow on salt as well? Like, does salt grow on those two bacteria
They're
as well?
not extremophiles.
They're not?
Also, then they're gonna die.
Okay. So then how will that affect the other things along with it?
Then the brine shrimp won't have as much time.
No.
Yeah.
The brine fly. Halobacteria grows.
During co-teach lessons, teachers took time-outs to share ideas they've heard from students and make decisions about how best to proceed to be responsive to students' current thinking. At points during the lesson, educators briefly stopped to discuss ideas that should be highlighted for the entire class, probing questions that fostered productive student discourse and trends among student ideas. This helped teachers successfully transition from small group talk to a large group conversation. After co-teaching, the team of educators debriefed by analyzing student work, student discourse through video, and identified successful teacher moves that fostered greater student understanding. Changes were made to the lesson to apply these ideas in the next co-teaching experience.
Continuously tying in evidence to why he was saying what couldn't exist in the salty North Arm. And so right after we said, okay, this literally water debate, he started giving his explanation. So this is what that video is. And you can't really see too much until the very end, but you can hear a lot.
Oh, Sean and Victor. Okay.
Which is good because this is the group that actually had a lot of trouble getting started. I don't know if you noticed it.
I
Who
can
has
see it
their
where-
work in front of them?
Yeah, good question. Who has their student work?
Oh, I do. Totally. Well, because this is, so we're talking, so we end up, sorry, key piece. So we end up talking as, okay, I need to show you, to write something. So I said, okay, let's put the halobacteria in fresh water and salt water and tell me what happens. And this is where he just goes off.
The host teacher leads the second co-teach, implementing the changes that came out of the prior debrief conversation. Her colleagues continue to attend to student thinking. After co-teaching twice, participants discussed trends and student ideas by analyzing work produced by the students, keeping in mind their year-long goal of helping students develop explanatory models and create evidence-based scientific explanations. Finally, teachers voiced takeaways about something they will try in their own teaching based on the teacher learning that took place today. As part of a larger picture of support, this job-embedded professional development opportunity provides ongoing real-time feedback throughout the day and offers an authentic space for teachers and other educators to analyze practice that fosters better student understanding. For more information about this or other science teaching practices, please visit our website at toolsforteachingscience.org.